In this module, we shall learn the properties of a hyperbola. A hyperbola is a set of all the points in a plane such that the difference of their distances from two fixed points in the plane is constant. Here, F1 and F2 are the foci of this hyperbola. In a hyperbola, the distance of a focus from the center C, the length of semi-transverse axis A, and the length of the semi-conjugate axis B are related as B square equal to C square minus A square. The eccentricity of a hyperbola E is equal to C upon A. Consider this hyperbola. Observe that the center of this hyperbola is the origin and the transverse axis is along the x-axis. The lines passing through the foci and perpendicular to the transverse axis meet the hyperbola at 2 points. Each of these lines is called a latus rectum. Thus, latus rectum is defined as a line segment passing through the focus and perpendicular to the transverse axis. Its endpoints lie on the curve of the hyperbola. Since the hyperbola has two foci, it has two latus recta. Let L be the length of the latus rectum BF2. The vertices and foci are shown here. If C is the distance of focus F2 from center O, then the coordinates of point B are C, L. Let's recall the standard equation of a hyperbola with its center at the origin and the transverse axis along the x-axis. Since point B lies on the hyperbola, its coordinates must satisfy the standard equation of a hyperbola. Substitute the coordinates of point B in the standard equation of a hyperbola and simplify. On simplification, we get L is equal to B square upon A. Recall that a hyperbola is symmetrical about the x-axis. Hence, the distance between A and F2 is equal to the distance between B and F2. Hence, total length AB can be written as the sum of the lengths of AF2 and BF2. On substituting the values of AF2 and BF2 and adding, we get the latus rectum AB as 2B square upon A. Thus, the latus rectum of a hyperbola is 2B square upon A. Let's see an example. We need to find the length of a latus rectum of the given hyperbola. The given hyperbola is 36y square minus 9x square equal to 72. First, let us convert the given equation into its standard form as shown. On comparing the equation with its standard form, we get a square equal to 2 and b square equal to 8. Recall the formula to find the length of the latus rectum. On substituting the appropriate values and simplifying, we get the length of the latus rectum as 8 root 2. Here is another example. We need to find the equation of a hyperbola given its foci and the length of latus rectum. It is given that the foci is 0, plus or minus 2 root 5. Notice that the x-coordinate of the foci is 0. Hence, the foci lie on y-axis. Therefore, the equation of the hyperbola is as shown. Call this equation 1. The length of latus rectum is 2b square upon a. As per the given information, it is 16. Hence, 2b square upon a is equal to 16. This implies that b square is equal to 8a. From the given foci, we get the distance of a focus from the center C equal to 2 root 5. Recall the relation between the length of semi-transverse axis, semi-conjugate axis, and the distance of focus from the center. Call this equation 2. Substituting the appropriate values and simplifying, we get a square plus 8a minus 20 equal to 0. On further simplification, we get the values of a as minus 10 and 2. But a cannot be negative since it is the length of the semi-conjugate axis. Thus a is equal to 2. This implies that a square is equal to 4. Thus b square is equal to 16. Now, let's substitute the values of a square and b square in equation 1 and simplify. On simplification, we get the required equation of the hyperbola as 4y square minus x square equal to 16. Let's recall what we have learnt in this module. We have seen the properties of a hyperbola. We have also determined the length of the latus rectum and applied the same in solving problems.